Beneath the shimmering surface of our planet's oceans lies a realm so vast and so empty, it defies the imagination. The North Pacific Subtropical Gyre, an immense system of swirling currents, spans an area of nearly 37 million square kilometers, dwarfing even the largest land deserts. Together with the South Pacific Gyre, these aquatic deserts cover a staggering 40% of Earth's surface. But unlike the shifting sands of the Sahara or the frozen wastes of Antarctica, these oceanic wildernesses are nearly invisible, their emptiness hidden beneath the endless blue. Yet their scale is only the beginning of the mystery. Imagine a stretch of sea so immense it could swallow every river, every mountain, every desert on land, combined. This is not simply an expanse of water. It is an ecosystem defined by scarcity, where nutrients are so limited that life itself is forced to the margins. Scientists call these regions ocean deserts, but their reality is even more extreme. Here, sunlight filters down but rarely sparks the riotous blooms of plankton seen elsewhere. Instead, the water is crystal clear, eerily silent, and hauntingly empty. Recent research has revealed that these gyres are not static. They are changing, and not always for the better. In March 2024, scientists published startling findings. Nutrient inputs from land and air, including agricultural runoff and atmospheric deposition, are now intensifying the spread of low-oxygen dead zones within these already barren gyres. The result? Expanding regions where even the few hardy creatures that once survived can no longer find enough oxygen to live. These hypoxic zones are now some of the fastest-growing threats to marine biodiversity anywhere on the planet. But what causes such vast emptiness in these ocean deserts? It begins with the very currents that define the gyres. As water spirals inward, it traps heat and isolates itself from the nutrient-rich upwelling found at coastal margins. The result is a vast pool of water where nutrients, nitrogen, phosphorus, iron, are scarce. Without these vital ingredients, most marine life cannot thrive. The North Pacific Subtropical Gyre is the largest contiguous ecosystem on Earth, yet it supports only a fraction of the life found in coastal waters. It is a paradox, an ecosystem defined by what it lacks. These aquatic deserts are not just a scientific curiosity. They play a crucial role in regulating the planet's climate. The gyres act as massive carbon sinks, drawing in carbon dioxide from the atmosphere and locking it away in the deep ocean. But as dead zones expand, their ability to absorb carbon may change, with consequences scientists are only beginning to understand. The delicate balance between ocean chemistry and atmospheric carbon is one of the most profound and least understood systems on Earth. And then, there are the secrets these gyres hide. The South Pacific Gyre, stretching between Australia and South America, harbors the infamous South Pacific Garbage Patch, a swirling graveyard of marine debris and plastic particles. Here, in the heart of the ocean's emptiest quarter, human impact lingers in the form of pollutants and microplastics, slowly shaping the future of these vast blue deserts. Exploring these gyres is a journey into the unknown. The emptiness is deceptive. Beneath the surface, scientists have discovered organisms adapted to survive at the very edge of possibility. Microbes that feed on trace chemicals, plankton that drift for years without finding food, and mysterious signals in the water hint at life forms we have yet to catalog. Every expedition into these ocean deserts brings new questions, new marvels, and new threats. The ocean gyres remind us that the greatest wilderness left on Earth is not on land, but beneath the waves. They are realms defined by scarcity, by scale, and by secrets. In their silence and emptiness, they challenge everything we think we know about life, about survival, and about the fragile balance of our planet. To understand the mysteries of the ocean deserts is to glimpse the limits of life itself, and to realize how much remains to be discovered.